Alright, so our notes today are for simplifying rational functions. We've actually done this a lot already, especially with finding points of discontinuity and graphing with points of discontinuity. And really it's the exact same thing, okay? If you look at your rules, the first thing is to factor, okay? Don't be the person that does this. You look at the expression and go, oh, x squareds, they can cancel out. They actually cannot, because they're part of a bigger expression, okay? And I put in a public service announcement that every time you do this, a puppy dies. I used to say a grade dies, but people care more about puppies than they do their grades. So, hence I changed it. And look at how cute that guy is. All right? So, to simplify, a lot of times to make sure we don't do that, I say put parentheses around your expressions from the start. That tells you either the entire expression gets canceled out or nothing of the expression gets canceled out. So if you look, they're not the same, so we go straight into factoring. Okay, and so at the top, what multiplies to negative 18 adds up to negative 3. Again, the factors of 18 are 1 and 18, 2 and 9, 3 and 6. Okay, because 18 is negative, one of the factors need to be negative, and since 3 in the middle is negative, it's the bigger of the two factors. And in this case, 3 and negative 6 add up to negative 3. So this factors to x plus 3, x minus 6. And then on the bottom, what are the factors of 6 to add up to negative 7? So here are the factors of 6. Because it's positive, either both factors are positive or both factors are negative. Since the 7x is negative, we need both factors to be negative. And again, here's the set that adds up to negative 7. So x minus 1, x minus 6. And as you can see, the x minus 6 is the same on top and bottom, so we cancel those out, and we rewrite our answer of x plus 3 over x minus 1. And we have simplified that expression. Okay? The next type of problem is if you're multiplying two rational expressions. Guess what? Same exact idea, it's just that we have double the rational function. So I like to say this is our double factoring problem. Okay, so again, put all the parentheses in. As you can see, none of them are the exact same expression, so we can't cancel them out right out. So now we have to factor. And go ahead and set up your parentheses here. And so with our first one, x squared plus 3x minus 4, okay, using the same logic we did before, what multiplies negative 4 adds up to 3, you're going to get x plus 4 and x minus 1. 4 plus negative 1 is 3, 4 times negative 1 is negative 4. Now on the bottom, x squared plus 4x plus 4, what multiplies to 4 adds up to 4, gets us x plus 2 and x plus 2. 2 times 2 is 4, 2 plus 2 is 4. All right, and we're going to do the bottom right, x squared minus 4x plus 3. What multiplies to 3 adds up to negative 4. Well, that's going to be x minus 1 and x minus 3. Negative 1 times negative 3 is positive 3. Negative 1 plus negative 3 is negative 4. Now, the expression on the top right only has two terms, an x squared term and an x term. When this happens, you are going to take out the greatest common factor between those. In this case, it's going to be 2x. And then inside, we're going to be left with x plus 2. Now, in this situation, a lot of us kind of get confused and we're looking for a 2x to cancel out with everything. Well, factors are always being multiplied together. So the 2 and the x are multiplied together, so we can separate them. And there we go. We're looking for 2 to cancel out with, or just a plain old x to cancel out with. So now we go through and we determine what's the same on top and bottom. Well, there's an x plus 2, and an x plus 2, an x minus 1, and an x minus 1. That's it. So that means our final answer is our 2x times x plus 4. And again, I put the 2x in the front because that's where it's accepted to put it. Can you put it behind the x plus 4? Yes, but again, like I said, technically you should put that monomial in front. And so then on the bottom, we have x plus 2 and x minus 3. And there is our simplified form when we're multiplying. All right, and last we have division. Division is just hidden multiplication. Okay, so let's put parentheses around everything. Okay, because the first thing somebody wants to do is say this x and this x can cancel out, and that is no bueno. So now, factor everything. Here you're going to take out an x, because again, x squared, x term, take out the greatest common factor. Okay, x minus 2 is not factorable, so we leave it. X is not factorable, so we leave it. X squared plus x minus 6. What multiplies to negative 6 adds up to 1? That would be positive 3 and negative 2. And we throw the x's in front. Now, here's where this becomes a multiplication problem. Because when you divide by a fraction, you're actually multiplying by its reciprocal. And so we call this copy dot flip. So copy the first fraction, change the division to multiplication, there's your dot, so we have a copy, a dot, and now we flip the second fraction. Okay, so whatever was on bottom is now on top, whatever was on top is now on bottom. Now we start looking through what's the same on top and bottom. We have an x minus 2 and an x minus 2. We have an x and we have an x. That's it. That's all we can cancel. So we have x minus 3 times x plus 3. And that's your answer. And so today we have just gone through how to simplify rational expressions.